Hi there, and welcome to this video on A-Level Chemistry for the AQA specification, focusing on the topic of alkenes and in particular on the addition reactions of alkenes. Hi, I'm Manisha from StudyMind, where we help you to revise A-Level Chemistry with our helpful revision resources tailored to your subject, your specification, and to you. If you're new here, please make sure to click that subscribe button, and whilst you're watching, please leave any comments down below about anything you're unsure of. If it's your first time watching, make sure to let us know so we can send you our free revision resources. We also have helpful timestamps to guide you through the video. So, let's get started. Welcome to lesson 2 of 3 in this tutorial, covering the topic of the addition reactions of alkenes. This is the second video in our series of 3 lessons covering alkenes. Here are the key learning objectives for today's lesson. First, we will look at polymerization reactions, then at intermolecular forces in polyalkanes. We'll then move on to polychloroethene and addition polymers. Here are the AQA specification points for today's lesson. Feel free to pause the video now and have a quick read through them before we begin. We'll start by looking at the electrophilic addition of alkenes. Alkenes undergo electrophilic addition reactions since they have double bonds. The carbon-carbon double bond is a region of high electron density, which makes alkenes very reactive and susceptible to attack by electrophiles. In electrophilic addition reactions of alkenes, the carbon-carbon double bond is broken. When alkenes undergo electrophilic addition, the double bond breaks and the atoms bond to the carbon atoms. Remember, carbon is able to make up to 4 bonds as it has 4 electrons in its outermost shell. Now let's look at the test for unsaturation. Bromine water can be used as a test for unsaturation. The alkene needs to be mixed or shaken with the bromine water solution. This can be used as a test from unsaturation, as there is a colour change from orange to colourless. This occurs when unsaturated compounds, also known as alkenes, are present. An electrophilic addition reaction occurs when bromine reacts with alkenes. When an alkene reacts with bromine water, a dibromoalkane is formed. This means that 2 bromine atoms are added to each of the carbons when the double bond is broken. The dibromoalkane that forms is colourless. Now let's look at the electrophilic addition reaction of ethene with bromine water. The first step is that bromine becomes polarised. So the bromine atom closest to the double bond has a delta positive charge, and the other bromine atom has a delta negative charge. As a result of this repulsion, the electrons in the bromine molecule are displaced to one side, which causes it to become polarised. Here's a diagram of how it happens. As the bromine atom closest to the carbon-carbon double bond has a delta positive charge, it is attracted to the region of high electron density of the double bond. This causes a bond to be formed between this delta positive bromine atom and one of the carbon atoms in the double bond. This causes the double bond to break. Remember that the electrons in the bromine-bromine bond are repelled further by the electrons in the carbon-carbon double bond, until eventually it causes the bond to break. This leads to the formation of a bond between one of the bromine atoms and a carbon atom, as well as the formation of a bromine ion, which has a -1 charge. A carbocation is formed, which is a positively charged intermediate on the carbon atom that has not yet formed a bond. The bromine ion with a negative charge approaches the carbocation and forms a bond with it. Remember, the lone pair of electrons in the bromine ion comes from the Br-Br bond that broke. This is what the process looks like. And this is the whole thing step by step. Again, here is a reminder of the test for alkenes where an orange solution goes colourless. Now we'll move on to look at the reactions of alkenes with HBr and some of the products that we can form. An electrophilic reaction takes place when alkenes react with hydrogen halides. Sometimes there may be an unsymmetrical alkene in the addition reaction. An unsymmetrical alkene is when the group of atoms attached to each carbon in the double bond are different. Propane is unsymmetrical as it has two hydrogens bonded to one of the carbon atoms and then a hydrogen atom and methyl group attached to the other carbon atom in the double bond. When an unsymmetrical alkene reacts with a hydrogen halide, two products are formed. The product that forms in higher quantities is known as the major product, and the one that forms in lower quantities is known as the minor product. The dominating product depends on the stability of the carbocation that is formed. During a reaction, a carbocation intermediate will be formed, and it's more stable when it has more alkyl groups, for example, CH3, attached to it. This is because the alkyl groups donate electrons to the positive charge of the carbocation, making it more stable. Here, we can see that the most stable is the tertiary carbocation. Finally, we'll be looking at some addition reactions with H2SO4. An electrophilic addition reaction takes place when alkenes react with sulphuric acid. This causes the production of alkyl hydrogen sulfates. The sulphuric acid acts as a catalyst in the reaction. If water is added to the alkyl hydrogen sulfate and the mixture is warmed, alcohols can be formed in a hydrolysis reaction. First, we have electrophilic addition. The reaction of cold concentrated sulphuric acid with ethene is shown here. Now we have hydrolysis. Here we can see the hydrolysis of the ethyl hydrogen sulfate by warming the mixture with water to form ethanol. This is the overall equation. We've now covered all the learning objectives for today's lesson. Feel free to skip back through the video and re-watch anything you didn't understand. We've now completed Lesson 2.
If you liked this video, make sure to catch our latest videos by subscribing down below and leaving a comment on a topic that you'd like to see a video on. Click here to watch more videos on our series of A-Level Chemistry, or visit our website studymind.co.uk for past paper compilations by topic and specification.